Hey, grade nines. So in our third lesson of the unit so far, what we're gonna go over is optimum area and perimeter. So I'm gonna skip over a lot of the parts in this lesson because I think most of it you should be able to do on your own. I mainly want to go over just how we actually identify different dimensions of a rectangle. So I just want to look at the first activity that we're given here. So we're asked to find the possible dimensions for a garden that is 36 square meters. So if we are told that it's 36 square meters, what we need to do is we need to identify what the possible lengths and widths are. The first part is actually pretty easy because really all you're doing is trying to think of two numbers that will multiply together to give you 36. And they have to multiply together because we know that area is equal to length times width. Hopefully you remember that from before. So what we're doing is thinking of all the different combinations so that when you multiply two numbers together, you get 36. Once you have those two different dimensions, what you are then doing is you're finding your perimeter. Now, I just want to explain it for the first one. Hopefully, the first two, just so it's clear. We're told that this is 1 meter, and the other one, the width would be 36 meters, and we can obviously switch this around. So our question here is, what is a perimeter? Well, to find the perimeter, all we're really doing is adding the sides together. So we can do 1 plus 36 plus 1 plus 36, which gives us 74. There is a different way I can approach this to make it a little bit easier. I can also do 2 times 1, because there's two lengths, and 2 times width, which is 36. So 2 times 36, and then I add them up. So 2, and this gives me 72, which gives me 74 altogether when I add them up. And I can do the same idea. I could follow the same idea here to find the perimeter for a garden of length 2 and a width of 18. I can simply do 2 times 2, and then I can do 2 times 18, and then add them up. So 2 times 2 is 4, 2 times 18 is 36, and then I add them up and I get 40, which is correct. So what I'm going to do here is think of all the different combinations for the length and the width. Hopefully you had some time to think about this. I'll just show you the answers here. So we know that 3 times 12 works, 3 and 4 and 9 work, and 6 and 6 work. Really what we're doing, I'm not sure if anyone's picking up on this pattern, we're really just finding the factors of 36. And then once you know what the dimensions are, then you can easily find the perimeter by taking 2 times the length plus 2 times the width. And in this case, I have 2 times 3 plus 2 times 12. And 2 times 3 is 6, and 2 times 12 is 24. And then that gives me a total answer of 30. So I'm just showing you how I got the perimeter for that. And I follow the same idea for these two as well, right? So that should be pretty simple. And of course, this last one is a bit of a special case. Not only is it a rectangle, it's a square. So a square is basically just a special rectangle, right? Where all the sides are equal. So if all the sides are equal, then we simply add up 6 4 times, or 6 times 4, which gives us a perimeter of 24. So what you'll notice here is that the dimensions that will give us the smallest perimeter is actually a square. And this is actually the case all the time. So if I give you a certain perimeter, let's say that I am giving you if I give you a certain area that I require, and I'm trying to figure out which dimensions would give me the smallest perimeter, what I'm really doing is trying to create a square. So an easy shortcut to do this, to find out what the side length would be, is I simply take the square root of the area. So if I'm given the area, all I need to do is simply take the square root of it, and that will give me the smallest possible, that will give me the dimension that would result in the smallest possible perimeter. So this is kind of the basis of what we're really doing here. And this is going to be extremely useful. And you can see the usefulness of this in real life. There's a lot of times where you want the least amount of perimeter. For example, when you're fencing, you ideally want a big area, but you don't want a big perimeter, because that means that you're going to need to pay for more fencing. So in this case, you would be looking for the smallest possible perimeter. And we find the smallest possible perimeter if we're given the area by simply taking the square root of the area. So I hope that kind of makes sense. And that gives you the dimension. You still have to figure out the perimeter, but that's pretty easy. All you have to do is really just add that side length 4 times, because it's all 4 sides are equal. What if you want to find the maximum area? So I'm going to go through this a little bit faster, but if you want to find the maximum area, if you're given a specific perimeter, and that's exactly what's happening here, we're given the specific perimeter limitations, and we're supposed to find out what the area should be. what we're going to do in this case is we are simply going to brainstorm what the different lengths and widths can be. So in this case, they're not multiplying to give us 20, but they need to, the length and the width have to have a perimeter of the total perimeter of 20. So what we're really doing is we're taking our length and our width, and I'll do it at the top here, and we're just ensuring that 2 times the length plus 2 times the width gives us, oops, that's supposed to be width here, gives us 20. So we verify 1 and 9 does work because 1 times 2 is 2, 9 times 2 is 18, and then together it gives us 20. And of course, how do I find the area? Well, this is the easy part now. Multiply the length and the width, which gives us 9 meters squared. So we're going to continue this on. So what other dimensions could you have? Well, I could obviously have a length of 1. What if I had a length of 2? And for all these, I forgot to mention, let's just assume that we're looking at whole numbers. You could obviously look at decimals as well, but let's just make life easier for ourselves and let's just focus on whole numbers so we don't have to worry about decimals here. So in this case, we have 2, and we know the other side has to be 8. And how do we know that? Because we have 2 plus 8 plus 2 plus 8, which gives us a total of 20 meters. And one thing you'll notice, a lot of people start noticing a little pattern here. To find the length and width that works, instead of trying to think of how they add up to 20, when you multiply each of them by 2, you could also make it a little bit easier for yourself. Just think of 2 numbers that add up to half of this, which is 10, because you know you're going to have to multiply it by 2. So 2 and 8 works because we know that together they add up to 10, but if I multiply by 2, I end up getting 20. And following this pattern here, I have 3 meters and 7 meters. And we can do the little math here. 3 plus 7 is 10. If I multiply by 2, I get 20. So this also works as well. You also might notice a bit of a pattern when we start doing this, and I'll actually complete the table here for you. Again, I'm hoping you actually have time to complete it yourself. In class, we're doing it together, but if you're watching from home, it's kind of different. You might actually notice a pattern when you're coming up with the length and the width. You'll notice that as the length increases, the width will at the same time decrease. And not a coincidence, right? They kind of have to balance each other out. So this one's increasing by 1 and this is decreasing by 1. So kind of reminds us of linear relations as well, right? So because of this, because of this pattern, you can actually easily find out what the length and width would be. And of course, once you know the length and width, we just multiply together to give us the area. So what do we notice again with the area? Which dimensions give me the largest area? In this case, I wanted to find the largest area. I noticed that it's the last one where the length and the width are the same. So once again, if the length and the width are the same, what does that really mean? That means that the rectangle is a square. So if I want to find the area of this is quite easy. All I need to do is multiply length times width, which is 5 times 5, which gives me 25. And that is the largest one there. So what I notice here is that if I want to find either the smallest perimeter or the largest area, all I really need to do is make my rectangle a square. So there's actually a nice, easy little formula for this. If I want to find the side length and I'm given the area of, if I'm given the area, sorry, and actually I made a mistake here. If I'm given the perimeter, of a rectangle and I want to find the dimension that will give me the largest area, all I need to do is take my perimeter and divide by 4. And that should make sense as well, because if you purposely want to create a square and I'm given a perimeter, if a square we know is a rectangle where all the sides are the same. So if all the sides are the same, we're basically just saying make sure that we're saying that if you have the whole entire perimeter, all I need to do is divide by 4 to find out what one of the lengths is, because it's divided equally into 4 equal parts. So hopefully that kind of makes sense. So all we're really doing here is taking our perimeter and dividing by 4 because the 4 sides are equal in this case. So as an example, if you want to maximize an area that is that you're given is 40 meters, if you're maximizing the area of a garden that is given 40 meters of fencing, what would the dimensions be if you're trying to maximize that area there? So we would take the 40 meters here and we simply divide it by 4. So if you're given the area, you take the square root. If you're given the perimeter, you divide by 4. So we take our 40 meters and we divide by 4 because we want it to be a square. So we take 40 divided by 4, which gives us 10. So that means that the side length here is 10. Once I know the side length, the follow-up question is, what is the actual area of the largest garden? Well, if I know that this is, if all the sides are 10 meters, then I can easily find the area by multiplying 10 times 10, which gives me 100 meters squared. And that's all I have to do in that case. Now, there are exceptions to the rules, but I'll be honest, the exceptions to the rules are not going to come up on the test. So don't worry about it. But if you're curious about this, this is something you are going to learn about in grade 10. You're going to be doing more of these problems, kind of talking about the exceptions to the rules. But just so you know, I'm not going to put this on a test. So that's why I'm not going to focus as much attention on this. For the cohort that's in class, we'll go over this together a bit more, but you don't have to worry about it for now, okay? But essentially, if you do trial and error, you can try to find the dimensions that maximize it, and it's actually not a square. That's really what you're trying to notice, that it's actually not going to be a square in this case. But I'll let you kind of play around with that. And that is it for today.